UDLD can be implemented in two different modes, and the mode you choose is going to be based on what your goal is. For example, when I'm implementing UDLD in a layer 2 environment, I want UDLD to not only detect the unidirectional link, but I want to make sure that UDLD behind the scenes, without it even knowing, helps protect my spanning tree topology from loops. So my method would be aggressive mode, and here's why. With normal mode, when the unidirectional link is determined, the port is going to be marked as undetermined. A syslog message is going to be generated to notify the administrator that it is a unidirectional link. However, the ports are still forwarding traffic. So since the ports are still forwarding traffic, BPDUs are still being exchanged, but in a unidirectional fashion. So how does that hurt our environment? Well, BPDUs are now missing in one direction. As a result, a blocking port might end up in the forwarding state when it shouldn't be, and now we have a layer 2 loop within our topology. So normal mode doesn't help us out with spanning tree protocol. Aggressive mode does, because what aggressive mode is capable of is trying to reestablish the UDLD neighborship by sending out 8 UDLD frames in 8 seconds, so one every second, and if all 8 of them go unresponded to, then the ports are put into the air disabled state. And once the ports are in the air disabled state, traffic can't flow in or out of those ports. They are essentially blocked. So from a spanning tree protocol perspective, they're not even an option anymore, meaning there is no layer 2 loop in that layer 2 topology. So aggressive mode also helps us out with spanning tree protocol. On top of that, although UDLD was traditionally designed for fiber links, if you want to use it on a copper link to detect a unidirectional link within that copper cable, meaning that it's only transmitting in one way and not transmitting back in the other direction, it can detect that only in aggressive mode. Only in aggressive mode. So if you're implementing it on copper links or you want to benefit spanning tree protocol, UDLD aggressive mode is the way you have to go. So how do we configure UDLD? Well, it depends on what you are trying to do. For example, if you're only trying to enable UDLD on all fiber optic links, you can do that in global configuration mode. You just type in UDLD enable and you enable normal mode for all of the fiber optic links. If you want UDLD aggressive mode, then you type in UDLD aggressive, and aggressive mode is enabled for all of the fiber optic links. However, if you want to enable it on an interface by interface basis or enable it on copper links, then you need to use UDLD port aggressive in interface configuration mode. That is the only option, UDLD port aggressive, for copper connections. If it's a fiber connection and you're doing it in interface configuration mode, then you could do UDLD port, which would enable normal mode. But like I said, if you're going to use UDLD, you might as well go all the way and also benefit from the spanning tree protocol help that it's going to give without it even knowing. Let's go over to ASW1, and on ASW1, let's configure UDLD aggressive mode on gigabit 0/1 and gigabit 0/2. Configure terminal, interface range, gigabit Ethernet 0/1-2, and we'll type in UDLD port. And as you can see, if I hit enter, it's going to enable normal mode, but it's not going to do anything because this is a copper interface. So I really need to put it in aggressive mode if I want my copper links to benefit from UDLD in this particular case. So we have UDLD enabled there. How can we verify UDLD? We can type in show UDLD. So let's go ahead and take a look at that now. on ASW1, show UDLD, and you can see it's pointing out the status for every single interface in this command. So port-enabled administrative configuration for fast Ethernet 0/1 is disabled. Port-enabled operational state is disabled. Current bidirectional state is unknown. What did we do? We did gigabit 0/1 and 0/2. So let's go down to that section, and we'll see what it says. It says here that port-enabled administrative configuration setting is enabled in aggressive mode. Port-enabled operational state is enabled in aggressive mode, but the current bidirectional state is unknown. And there's no neighbor cache information stored. Why is that? Because we did not configure the other end of the link for UDLD. It has to be configured on both ends if we want it to work, because it is a bidirectional communication that is determining whether the link is unidirectional or not. So let's go over to DSW1 in this case and go to global configuration mode. Interface, gigabit Ethernet 1/0/1. We'll type in here UDLD, port, aggressive. We'll hit enter. And if we go back to ASW1, let's see what our output is for show UDLD. Ooh, we'll even type in gigabit Ethernet 0/1. And what does it say now? Oh, look at this. It says the current bidirectional state is bidirectional, so it's working. UDLD frames going out, the echo coming back. It's wonderful. And it says the current operational state is advertisement, single neighbor detected out this particular interface. And we can see some statistics about what is happening. And you can even see the CDP device name. So CDP is helping out here in the background as well. Let's see if anything has changed. All right, so message interval, every 15 seconds we are sending out a message, and our timeout is 5 seconds. So I send out a UDLD message every 15 seconds. If I don't hear back from that device within 5 seconds, we have a unidirectional link. There's one more UDLD command that I want you to be very familiar with. Let's say you had an interface that was put into the air-disabled state by UDLD. You have fixed the connection. You replaced the fiber strand. You did whatever you had to do to make it work again. You need to reset that interface that was air-disabled by UDLD. Here is the command to do it. In privileged exec mode, you type in UDLD reset. And UDLD reset will reset all those interfaces that were shut down or put into the air disabled state by UDLD.